Hello, and welcome to this presentation, Getting Started with the HMF2500. In this presentation, we'll provide an introduction to how to configure and use the different functions and features of Rohde Schwarz HMF2500 series arbitrary function generators. This presentation assumes a basic knowledge of function or arbitrary waveform generators. If you're not familiar with this topic, or if you'd like a brief review, you might want to watch the presentation Understanding Function Generators before beginning this presentation. Let's start with a brief overview of HMF2500 series generators. There are two models of the HMF. The HMF2525, which has a frequency range of 10 microhertz to 25 megahertz, and the HMF2550, which has an upper frequency range of 50 megahertz. Both models have the same maximum output voltage, 10 volts peak to peak when operated into a 50 ohm load, and 20 volts peak to peak when operated into an open. The HMF is capable of generating both standard waveforms, such as sine, triangle, square, etc., as well as arbitrary waveforms made up of user-defined points. Created waveforms can be modulated using internal or external sources, and waveform generation can be controlled via an external trigger or gate signal. And finally, in addition to front panel controls, remote control or automation is also supported over a variety of physical interfaces. Let's start with a quick tour of the front panel. Soft keys are used for many configuration tasks and are activated by the hard keys to their right. Often these keys are dual function. Pushing a key alternates between two different functions. The 5 buttons along the bottom are used to select the waveform type, and numeric keypad and unit keys can be used to enter and modify basic waveform parameters, such as frequency and level. Values can also be changed and parameters selected using the rotary knob and cursors. Between the rotary knob and the keypad are the buttons for waveform properties, such as modulation and frequency sweeps. The B and C connector at the bottom right corner is the output for the configured waveform, and the buttons directly above it are the output controls. And finally, two additional B and C connectors are available for trigger input and output. Before we go on, it's worth pausing for a moment to talk about load impedance, which can be configured by pressing the menu hard key and then choosing System. The load impedance can be set to 50 ohms, user-defined, or high. It's important to set the load impedance appropriately, since failing to do so can lead to unexpected signal amplitudes. For example, if the load impedance on the HMF is set to 50 ohms, but the load actually has a high impedance, then the amplitude at the HMF output might be up to twice as much as the user-entered amplitude value. This is not an uncommon mistake when connecting generators and loads, so it's worth checking that this is configured properly. Note too that the configured load impedance is always shown in the top left corner of the screen. The first step in generating waveforms is to choose one of the 5 waveform types. These are sine, square, triangle, pulse, and arbitrary. To choose a waveform, press the hard key corresponding to each type. As we'll see on the next slides, soft keys are used to edit the waveform parameters, such as frequency and amplitude, with the numeric keypad or rotary knob and cursors used to set the numeric values. Let's look at an example of how soft keys are used to configure waveform parameters. Here we've selected a pulse waveform. We use the top soft key to toggle between entering frequency or period. Similarly, we can enter voltage either as high and low levels, or as an amplitude and offset. For the high width and low width parameters, toggling the hard key will switch between these values. And although duty cycle and edge time are both displayed, we can toggle between which value we want to edit. Remember that the numeric values are entered via the keypad or rotary knob on the front panel. Now let's spend a little time talking about arbitrary waveforms. These are waveforms that are defined by a user-created list of amplitude points. They're called arbitrary because the waveform can have any arbitrary shape or pattern. There are two methods for creating or defining arbitrary waveforms for use with the HMF. The first is in the form of a CSV or comma-separated value file. This file can be created manually, but usually an external program is used to define, import, and/or edit these points. For example, using points saved from an oscilloscope trace. These CSV files are loaded into the HMF using the front panel USB interface. Another method for creating arbitrary waveforms is using the free HM Explorer software package, which contains a graphic waveform editor and which can be used to upload the waveform directly into the HMF using one of the supplied remote interfaces. The HMF also comes with a set of built-in or preloaded arbitrary waveforms, including sine, square, positive and negative ramps, exponential rise and fall, etc. These are accessed by selecting arbitrary as the waveform type and then pressing the built-in waveform soft key. These built-in waveforms all have user-configurable parameters, for example, frequency, amplitude, offset, etc. In addition to being used as is, these built-in waveforms can also be used as modulation sources, a topic we'll come back to later in this presentation. To begin generation of the configured waveform, use the output hard key. This key will be lighted in white while the waveform output is enabled. The offset key is used to enable a configured voltage offset. A configured offset will not be applied until the offset button is pressed. The invert button inverts the polarity of the signal. Note that invert is available only for pulsed signals. By default, waveforms are generated continuously and immediately when the output hard key is pressed, but signal generation may also be triggered by some external event. The trigger source setting, immediate or external, is accessed by pressing the menu hard key and then System Trigger. The HMF supports three sources of external triggers. The first is the rem trig button on the left edge of the front panel. A TTL signal at the trig input BMC connector can be used as a trigger, and triggering can also be activated via the appropriate remote control commands. One thing to note is that triggered signals are synchronous. That is, the waveform will start with the initial phase value when the trigger signal is received. The HMF can also sweep the frequency of the waveform during generation, and this is configured by pressing the sweep hard key. Signal frequency is swept over a user-defined time interval. For example, here we're generating a sine wave whose frequency sweeps from 1 MHz to 10 MHz over a period of 5 seconds. Note that the spacing can be either linear or logarithmic. If the stop frequency is set greater than the start frequency, the sweep will be run from high to low. Sweeping is continuous by default when enabled, but can also be started using an external trigger at the trigger input connector. In addition, a marker frequency can be defined. When the sweep reaches this frequency, a signal will be generated at the trigger output connector. Let's look at an example. Here, the output frequency sweeps between 1 and 10 MHz over a period of 5 seconds with linear spacing. Since we're using the internal clock to trigger the sweep, this sweep is repeated continuously. The next special mode is burst mode, which generates short periods or bursts of a waveform. These bursts are primarily defined using two parameters: period, or the time between the bursts, and cycles, or the number of cycles within the burst. We'll look at an example of these parameters on the next slide. Optionally, the phase of the burst can also be configured. The bursts can be sent continuously and immediately, which is the default behavior, or they can be initiated via a manual or external trigger. Let's look at an example of burst mode. Here we've configured a period of 1 second and 5 cycles. Looking at the resulting waveform on an oscilloscope, we see bursts of the waveform, each 5 cycles long, with the distance or time interval between the start of each burst being the user-defined period of 1 second. Bursts may also be gated, that is, the waveform will be either on or off, depending on the signal level at the trigger input connector. In other words, the waveform will be output only when the gate signal level is high. For example, here the gate signal is shown in green. The output waveform, in yellow, is being generated when the gate voltage is high. In this example, the gating is synchronous. Each burst starts at the same initial zero phase value. But it's possible to have an asynchronous gated burst, in which case the initial phase may vary between bursts. Our last topic is modulation, which is selected by pressing the Mod hard key. Once a waveform has been configured, that waveform can be amplitude, frequency, or phase modulated, or a pulse width modulated, or binary frequency shift keying waveform can be generated. Each of these modulation types has its own configurable parameters. For example, modulation depth in the case of AM, or deviation in the case of FM. The shape parameters used to select the type or shape of the modulating waveform, that is, the signal being used to modulate the waveform. This can be one of the built-in functions, or it may be a user-created waveform. Let's look at a few examples. We'll start with a sinusoid being AM modulated. If we choose an AM modulation depth of 80%, we'll generate the waveform shown. Changing the AM modulation depth to only 20% results in a waveform with much shallower peaks and valleys, that is, a smaller distance between the max and min waveform amplitude. If we leave modulation depth at 80%, but instead change the shape of the modulating waveform to a positive ramp, we can see the waveform amplitude increasing linearly over time. On the other hand, changing the shape to exponential fall produces a waveform whose output voltage decreases or decays exponentially. FSK, or frequency shift keying, is a form of signal modulation where the carrier frequency shifts between two or more frequencies. The HMF supports binary frequency shift keying, where the switching is between two frequencies. These are called the carrier frequency and the hop frequency. In addition to configuring the hop distance in hertz, the switching speed or rate must also be defined. In internal source mode, this is specified using the rate parameter. For example, here we see the two hops, and the time interval between them is the inverse of the switching rate. Switching can also be controlled via an external signal at the trigger input connector on the front panel. Pulse width modulation, or PWM, is only available for pulse waveforms. In PWM, the width of the pulse is controlled or determined by the modulating signal. The deviation parameters used to define how much the width of the pulse signal will vary with changes in the modulating signal. For example, if the unmodulated waveform is a pulsed signal with a duty cycle of 20%, and we apply a pulse width modulation with a deviation of 5%, then the duty cycle of the output pulsed waveform will vary between 15 and 25%. Before we conclude this presentation, let's briefly cover the rear panel connectors, starting with the modulation input. As we discussed earlier, a DC signal at this input can be used to control the amount of modulation applied to the output signal. An input voltage from 0 to 5 volts maps linearly to a modulation percentage of 0 to 100%. The sweep out connector provides an output voltage that linearly follows the sweep from the start to the stop frequency. The HMF also has a reference in and reference out connector, which allows it to both use an external frequency reference for higher accuracy and/or allows it to share its own internal frequency reference with other devices. And finally, the HMF comes standard with both USB and RS-232 for remote connections, with Ethernet or GPIB as options. These interfaces can be used for remote control, file transfer, making screenshots, etc. Let's end with a brief summary. Rohde Schwarz HMF2500 series arbitrary waveform generators can create a wide range of output waveforms. The most common of these are simple functions such as sine, square, triangle, etc., but the HMF also comes with a number of predefined functions. Furthermore, users can define their own arbitrary waveforms of any shape. This can be done in the form of CSV files or by using the free HM Explorer software utility. Waveforms can be modulated in a number of ways, using either internal or external modulation sources. In addition, the HMF supports external trigger in and trigger out signals, and these signals can be used to gate the generator output. And finally, the HMF's remote interfaces allow it to be controlled and managed externally. This concludes our presentation, getting started with the HMF2500. If you'd like to learn more about generators, how they're used, or generators from Rohde & Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.